Okay, so anyway, let's continue with the discussion. So, um, nawala to akong ang audio sa akong OBS ba. So, muna ako siyang i-reset. Okay, so to continue, so let's start now with the discussion of the examples. So we're going to try to solve 9 examples for this session. So mabura na siya because again, since you're looking at simple na mga examples, so probably dali na maabot sa number 9. Okay, so let's start with number 1. So again, if you try to look at the example, so you have the integral of x times e raised to the 2x dx. So probably if you can notice that you cannot use simple u sub technique because the exponent is 2x and then you have the x variable. So the other way to do this is again by the use of integration by parts. So let's try to inspect again the different functions in our integrand. So again, you have here an algebraic term, and then the other one is an exponential term. So again, let's try to, so algebraic, and then the other one is exponential. So again, as per definition, it's the product of two different functions. Okay, so that's where um, this is where you're going to use integration by parts. So in integration by parts, so aside from all the text that has been presented in the previous slide, so probably the most efficient way to do it is by showing you the solution or how you're going to use integration by parts in your solution. So first you need to do is again, you write u here, and then the other one is dv. So muna siya diagonally situated sa inyong u and dv. So the purpose of this one is we're going to derive u, then we're going to integrate dv. Okay, so that's the whole process of integration by parts before applying the formula uv minus v du. So again, as what the text explained, so we try to choose the complicated term as our dv function, and again, don't forget that we need to include dx in our dv. So most complicated term, algebraic against exponential. So of course, the exponential term is difficult. So we try to write it here as e raised to the 2x. So again, don't forget dx. Of course, the other term would be just x variable for the u parameter. Okay. So upon integrating or upon integration, so we try to get du as dx. And then your v. So again, hopefully by now that you are able to be, you are now quick in integrating such function, exponential function. So this would be 1/2 e raised to the 2x. So wala lang plus siya because this will be part of the formula later. So again, if you're going to ask me why it's 1/2 e raised to the power of 2x, so I just use the formula. Okay, so now we're going to use the formula now. So the formula is uv minus the integral of v du. So dali ra siya, di ba? Since there's a format for the integration by parts. Unlike the other concept or the advanced techniques, so we are going to use the kanang processing, di ba? Katong mga steps like in the previous discussion, there are 6 steps or 6 major steps that you're going to use for you to be able to solve the equation, di ba? So kanisha is you just have to determine v, determine u, also du, then apply it within the formula. So mura na siya inyong button for this particular technique. Okay, so uv, that would be x times 1/2, or you can just say it as 1/2 x times e raised to the power of 2x, and then minus v du. So that would be 1/2 e raised to the power of 2x, and then du is just dx. Okay, so making it more simplified by taking 1/2 outside. So you have 1/2 integral of e raised to the power of 2x dx. Okay, so upon integration, so you have here 1/2 x times e raised to the power of 2x, then minus 1/2 times 1/2 e raised to the power of 2x plus c. So the final answer would be 1/2 x times e raised to the power of 2x minus 1/4 e raised to the power of 2x plus c. So this is your final answer. So any questions for number 1? Okay, so wala ra. Okay, so let's proceed with number 2. So this time is we're going to have the integral of x times secant squared x dx. So again, if you're trying to determine the functions involved in the equation, so you have here algebraic and then against trigonometric function. So again, we're still going to use integration by parts because you have two different types of functions. So again, the steps would be you have to determine u and then you have to determine dv. So dv should be the most complicated term along with dx. So since trigonometric is much more complicated compared with algebraic, so we try to write it as secant squared x dx. And then your u should be x only. Okay, so integrate deriving first u parameter. So you have du is equal to dx. And then integrating dv. So the integral of secant squared x is just tangent x. All right. So getting the formula. So you have uv minus the integral of v du. So uv would be x times tangent x, and then minus the integral of, so v du, so that would be tangent x dx. Okay, so integral of tangent x is just ln cosine mo to. So x tangent x, and then minus the ln of, probably it's cosine mo siguro, or so let's try to check ha. Okay, it's rarely seen to have integral on good of tangent. Okay, so that's negative ln cosine u. So again, since it's negative, so probably you can just have it you can have the positive value of the negative ln cosine. So instead of negative ln cosine, you have ln secant x plus c. So again, the other answer would be if you're going to have x tangent x minus and then minus pa dyan, di ba? Minus negative ln of cosine x plus c. So the other answer would be or x tangent x plus ln cosine x plus c. So other answer for this item. All right, so questions for number 2. So simple siya, di ba? So pwede rin tamo humanda yun, ani. So how about for ln x? So again, as per definition in the first slide, so it's you can use integration by parts if you are integrating logarithms. So you have the natural logarithm of x dx. So again, we have no such formula for the ln function. So that's why we're going to use integration by parts for us to be able to solve this equation. Okay, so again, notice that you only have logarithm here. So even though that the first statement of or the first description for integration by parts is the product of two different functions, so of course this can also be the product of two different functions. So let's say the coefficient of dx is 1, di ba? So 1 could be expressed as algebraic, di ba? So same gyapon siya. Okay? So again, you have to start with the U parameter and then looking for dv afterwards or vice versa, depending on what you're going to do. So to start off, since we cannot integrate ln x, even though that it's a complicated function compared with the algebraic term, so we cannot put it in dv, di ba? Kay nag-integrate na kita sa ln x, imo pa yung ibutang sa dv na dito na kita integrate, di ba? So we try to put it in the u parameter because I think it's much easier for us to derive ln compared with integrating it. And then this one is just dx. All right. Okay, diba? So even though that you have to choose dv as the most complicated term, another tip that the first slide gave is that dv should always be integrable. So even though that it's complicated, it can be integrated. So muna siya ang iyahang kan. Okay, so deriving u parameter, you have du. So again, as per differential calculus, derivatives. So the derivative of ln is du over u. Diba? So this one should be dx all over x. And then integrating dv, so you're going to have x variable. So that's how you answer logarithm na mga integration by parts. So, I think if you try to if you're going to encounter ln in your integrand, so always make sure that ln is in the u parameter para ma-eliminate tayo siya. Okay, so again, formula. So uv minus the integral of v du. Okay, so ln x times x. So probably the best way to write it is rather x times ln x minus the integral of v du. So that would be x times dx over x. So since the x can be cancelled, so we can rewrite this one as x ln x minus the integral of dx. So the final answer would be x ln of x minus x plus c. So sayo na kaya itong mga example, di ba? Compared sa first two techniques, which is a bit complicated if you're going to ask me. Alright, questions? Okay, so no questions. So before we proceed with the second, rather the fourth example. Okay, so wala. Okay, so this time is we go to the integration of your arctangent square root of x. So again, this term here is again inverse trigo. So of course you can imagine there's a one coefficient in dx. So this one is the algebraic portion. So it's still the product of two different functions. Okay. So again, if you try to imagine, we don't have any integrals for arctangent. So we do have for inverse trigo functions, but again, we need to um, follow the format, diba, katong du over a squared plus a squared plus u squared. So not integrated using a given of inverse function directly, di ba? So if inani ang given sa inyo ang integrand, so we have to use integration by parts. So you set it as u, and then this one is dv. So again, we cannot put arctangent in dv because we're nagkalisod na kita integrate taan pa lang sa given, di ba? And then you try to put it in dv niya. Mag-integrate ito sa dv, di ba? So hindi na siya pwede diya nga kuan. So always write it in arctangent as the u parameter. So dv is just dx. Okay? Okay, so integrating arctangent. So derivative of arctangent is dx all over 1 plus x. Lakuratan silang ano, 1. Ano, 1 plus x ra ang nakabutang. So again, don't forget that the inverse trigo functions are just the opposite of the other, diba? So in terms of derivative, in terms of integrals, they're just the opposite of each other. So a squared is 1 because there's no coefficient, diba? It's just arctangent directly. The u parameter is square root of x. So a squared plus u squared, that would be 1 plus the square of the square root of x. So you cancel out the square root, that's why it's now x, 1 plus x. All right? So this one is v parameter. So it's just the x variable. Okay, so next is we try to use the formula now. So uv minus the integral of v du. So uv is, you have here as x arctangent x. So ako lang iuna ang x because bati tanaw ng arctangent square root of x, di ba? Wala siya dyan na kita naon. So x arctangent square root of x, and then minus v du. So that would be x times dx all over 1 plus x. So you have it here as x arctangent square root of x minus x dx over 1 plus x. Okay. So again, if I'm looking at the right or the, the term with the integral symbol, so that's x over 1 plus x. So again, if you're going to have the same degree or exponent in your fractions, so you may use long division. Okay, so 1 plus x, so let's try to use long division. So 1, and then you have here x plus 1. Then subtract it. So what is left is just negative 1. So it can be written as 1 minus 1 over 1 plus x. Okay. So next would be, again, rewriting the equation. So that would be x arctangent square root of x, and then minus the integral of 1 minus 1 over 1 plus x, then dx. Okay, so this one is just x variable. This one is ln of 1 plus x. So it's ln of 1 plus x because let u be 1 plus x, and then du is just dx, diba? So you're going to have it as the integral of du over u, and that would be ln. Alright, so the final answer is now x arctangent square root of x, and then minus x variable, so minus, so notice that it's minus. So be careful with the next term. So it's minus minus, so you have the third term as plus ln of 1 plus x, and then plus c. So don't forget the plus c. Okay, so that's your final answer. Okay, so questions for number 4. So marag kami questions ano no kay simple jud kay siya nga topic. So let's try a more complicated example. So you have here cosine, the integral of cosine x times ln sine x dx. So how are you going to solve this one? So again, let's try to you have here cosine x, then you have here ln sine x dx. So this one is trigo function. This one is log plus trig, yeah, so it's a bit complicated. So usually if you try to solve it in your paper kind of on your own, so usually what I try to do first is I try to write u, and then ako na siya yung ln. Okay, maglisod ko if I'm going to write dv directly kay di siya matupong ba. Okay, and then du will be du over u, diba? So you have cosine x all over sine x dx. So that's how I try to solve the equation. And then I'm going to write now dv. So maragtupong siya sa du. So that would be the other term is which is cosine x dx. So the v term here in integrated, so that would be just sine x. So again with the formula uv minus the integral of v du. So we're going to have sine x ln sine x and then minus v du. So that would be sine x times cosine x all over sine x dx. So cancel out sine x, cancel out sine x. So this would give you the final answer of sine x ln x, rather ln sine x minus sine x plus c. Alright? So even though murang complicated siya tanawon, so just try to use the formula. So try obtaining u and then v. Okay. Okay, question. Minus cosine x ang sa man. Integral man sa cosine. So that would be sine x. So kani siya ang nakabili nga term kani. So don't forget na that you have to integrate ha. So ta formula. Okay, so let's try second cube x dx. So medyo makarata na tayo dito kay it's cube, di ba? So second cube x dx. Okay, so if you're going to have multiple angle, so the best way to do this is you try to dissect it into two different sections. So what I mean by that is that you're going to have one as let's say second squared times second x ana. Lagi mo siyang i-dissect into two different factors. Nga if mo siya i-multiply balik, it's just equivalent to second cube x. Okay, sorry. Okay, so again, if you try to rewrite this one, this can be represented as second x times second squared x times dx, so that we can have a better view of the problem. So of course you can just try to answer this one also as katong type B, di ba? Type B. So if you have forgotten what type B is, so that's the tangent and secant na pair up, di ba? So probably you're going to use the type type B case number 2. Pero probably this one isn't found in the case because dapat ni siya square, di ba? For you to be able to solve this one. So nevertheless, you can just try to answer this one with integration by parts. So this is how you do it. So you start off with u and then, so this would be secant x because again, mas complicated ang na exponent, diba? Compared with having a linear exponent or one exponent. So derivative would be du is equal to secant x tangent x dx. So for dv, you have secant squared x dx, and then v would just be tangent x. So integral of secant squared x is just tangent x. Okay, so with the formula, I now have secant tangent. So secant x, so let's try to put the formula first. So uv minus the integral of v du. So you have here secant x tangent x, then minus the integral of v du. So that would be tangent x, and then times secant x tangent x dx. Okay, so you're going to have secant x tangent x, then minus the integral of um, secant x tangent squared x dx. So again, as per the formula, or rather as per type B, so since m is even, so we're going to apply the rule, which is we're going to apply the Pythagorean identity. So secant x tangent x minus secant x, then this one should be secant squared x minus 1 dx. Okay, so you're going to have now secant x tangent x minus the integral of secant cube x, and then minus secant x. So nana siya dx dx, and then this one has also a dx. So notice na nibalik na punta sa secant cube, di ba? Ano siya? And then the integral of secant x would just be the ln of secant u. So let's try to check. So ln of secant u plus tangent u, di ba? So muna siya ang inyong secant. So if we try to integrate this one, so this would give us negative. Oh, this one is plus then, no? Plus. So plus siya because the first term is negative. The other term is positive, minus minus. So again, the integral for this one is ln of secant u, either secant x plus tangent x plus c. As per formula na siya. Okay. So usually if we try to answer this one, equal sign, diba? Equal sign in reference with the given example. So this should be equal to, diba? Usually ang atong way of solving the equation is the original equation equals the solution, diba? Muna siya atong the proper way of solving equations. So x tangent x, then let's say you have plus ln of secant x plus tangent x, and then the integral of secant cube x dx. Okay, so what you need to do here, since di ba ang given nasa left side, ang nasa right side is the solution, di ba? And notice that you have a repetition of secant cube x dx. So atong baton, ato siyang ibalhin sa other side. Kaya ma-combine man sila, di ba? So you're going to have on the left side 2 integral of secant cube x dx. So name mo siyang duha, di ba? Kay the given, and you have another term on the right side, which we combine on the left side. Then equal to secant x tangent x, then plus ln of secant x plus tangent x. Then you divide everything by 2, and then the answer would be 1 half secant x tangent x plus 1 half ln of secant x plus tangent x, then plus c. So of course, c divided by 1 half is just c. Diba? So muna siya inyong final answer. So again, what we did is that later on when you're going to encounter repetition of your original equation, so what we normally do is we just try to combine it on the left side para wala tayong integrate, diba? Kaya if we try on repeating the process, let's say magsige mo integrate ani, magsige na siya balik jud, di na siya ma-eliminate ang kanina integral kay magsige mo siya balik-balik, diba? So wala siya ma-eliminate sa equation despite that we are using integration by parts. And then since the term is recurring, or let's say it's repeating, so we have to combine it with the original equation, which is on the left side of the equation always. Okay, so probably you're confused why I combine it with the original equation, but again, normally what we do in mathematical calculation is that, for example, this one is the given, diba? So equals to, and the right side should always be the solution. So of course, magsuwat sa solution, naman, di ba? Yan, dapat, originally, ang proper way na is, every line you always have to rewrite the given equals the next step of the solution. But since it's pretty kanang hassle, di ba? Magsikita og suwat sa given, so that's why wala kayo siya nga portion, di ba? Usually sa dito sa final answer ta mo nya ato ba i-box, di ba? So muna siya inyong i-try to remember. All right. So questions for number 6. Ang basta mobalik siya sa equation, yun siya i-combine lang. Kani siya. Ni-repeat man siya. Yeah, take note that dapat negative mo siya. Negative sa given. Okay, para ini ka transpose niyo sa, di ba, ang transpose na rule, di ba? When you transpose to the other side, it becomes the kanang kuan, opposite na value. So di siya pwede. Di siya pwede. If positive na siya, di siya pwede. Okay, if plus ni siya, and then you're going to combine it on the other term, okay, ma-zero out na inyong left side, diba? So, di na siya equal. Dili pa sad, magsige pa continue until you reach a negative version of the given function. Kaya probably I think ang best way siguro ani to explain the left and the right side is kato siguro ang topic ninyo sa trigo, which is katong proving katong proving. So di ba dapat niyo i-prove ang kani nga left side must be equal to the right side, di ba? So murag mo na siya nga topic nga dapat nakahanay siya, di ba? So just think of this as that particular topic. Left side then right side na. Okay, so let's go to example number 7. So we have here exponential against trigonometric. So again, to start off, we try to get the u first. So we have it as cosine x. So cosine x lang because again, so again, depende na ninyo if you're going to use e to the power of x as u because both are complicated, diba? Cosine and exponential, but for me, mas complicated yun ang exponential. So that's why I want it as dv. So derivative of cosine is negative sine x. So again, either way is acceptable if you want to let your u as e to the power of x. So dv is e to the power of x, and then getting the integral, so not actually dx. So same, it's still e to the power of x. Okay, so let's try to again use the formula. So di na ako i-write ng formula, kaya balik-balik na siya. So e to the power of x cosine x minus e to the power of x. So na siya dx there. I forgot to write dx. Then minus sine x dx. So in simpler terms, this is e to the power of x cosine x. Then you now have plus because minus and then minus. Integral of e to the power of x sine x dx. So again, looking at the the remaining integral, it's not yet a simple version, diba? It's still a product of two different functions. So we have to use integration by parts again. So let u is equal to sine x dx. No, sine x only. Then du is now cosine x dx. Then my dv parameter is still e to the power of x dx. Then integrating it would give me e to the power of x. So again, with the use of the formula, I'm going to have e raised to the power of x cosine x. So copy first the remaining term here. And then plus. So I try to enclose it in a parenthesis because it's a long expression, diba, for the formula uv minus vdu, and I want to take note of the sign, ano yung mga signages. Yeah, inika-multiply na ako later inside the terms of the parenthesis. So muna siya kung murag safety precaution always if I'm going to plug in murag a longer term, di ba? So uv, so that would be e to the power of x. Then you have here sine x. Then minus v du. So e raised to the power of x cosine x dx. So taking the parenthesis off, so plus, this is still plus, this one is still minus. So e raised to the power of x cosine x, and then plus e raised to the power of x sine x minus the integral of e raised to the power of x cosine x dx. So notice that nibalik na sa ang inyong given, di ba? And it's a negative version of the given equation. So that's the time that we can combine it on the left side, ba? Transpose on the left side, kuyog sa given equation. So what you're going to have now is 2 integral of e to the power of x cosine x dx is equal to e to the power of x cosine x plus e to the power of x sine x. Then divide everything by 2. So na siya plus c dira, plus c. Then divide everything by 2. So the final answer would be yung integral of e to the power of x cosine x dx is equal to 1/2 of e raised to the power of x cosine x plus e raised to the power of sine x plus c. Or you may try to factor out some terms here. You can have it as 1/2 e raised to the power of x and then cosine x plus sine x plus c. So pwede po siya aning a version. All right. So you have examples number 6 and 7 for you to review later kung ano na-combine ang two different functions. As long as nibalik ang original equation and it's a counter sign of the given equation, so it's minus. So you can combine that, diba? Using transpose na method, diba? So transpose on the left side, that would this would become plus integral of e to the power of x, diba? Then since you have two equations of the given expression, so you can create it as twice that given expression, diba? Which is this term here. Okay, so questions before we proceed with example number 8. Okay, sige. So example number 8. So we have here x squared e raised to the power of 2x dx. So, so to start off, we have here u, and then, so of course, I'm going to have it as x squared. Then this one is 2x dx. Okay, so dv would be e raised to the power of 2x dx. And then my v parameter would be 1/2 e raised to the power of 2x. So again, ano 1/2 e to the power of 2x siya, I just used the formula for the exponential expression. So eu du, di ba? So let u be 2x, and then du would be 2 dx, di ba? So manamay mo siyang du over u. Okay, so we have now 1/2 x squared e raised to the power of 2x. So ako lang siyang i-arrange na kay para nice na siya pag-akuan. And then minus v du. So that would be the integral of 1/2 e raised to the power of 2x, then multiplied by du 2x dx. Okay, so rearranging it again. So x squared e raised to the power of 2x minus 1/2 the integral of x e raised to the power of 2x dx. So take note that it's still a product of two different functions, x and then exponential 2x. So it's still algebraic against exponential function. So again, we have to do again integration by parts. So most likely in some of the problems, in most cases, at least twice mo mag-integration by parts, or worst case scenario, thrice. Okay, so let u be equal to x, and then du would be equal to dx. So dv is still equal to e raised to the power of 2x dx, and then the same v, which is 1/2 e raised to the power of 2x. Okay, so you're going to have, so again, don't forget to isolate the given integration by parts nga process. So x squared e raised to the power of 2x. So notice that after I write negative 1/2, so I enclosed everything with another parenthesis, diba? So this becomes uv, so that's x 1/2 times x e raised to the power of 2x minus v du, integral of v du. So 1/2 e raised to the power of 2x dx. So distributing negative sign, di ba? Negative 1/2. Negative 1/2 to the first term and then to the next term. So this becomes 1/2 x squared e raised to the power of 2x, and then minus 1/4. So 1/2 times 1/2, that will be 1/4, and then x e raised to the power of 2x. So minus times minus would be plus. So this would be plus 1/4 integral of e raised to the power of 2x dx. And then the final answer would be, so integrating e to the power of 2x is just 1/2 e to the power of 2x. So final answer would be 1/2 x squared e raised to the power of 2x minus 1/4 times x e raised to the power of 2x, and then plus, so 1/4 times 1/2 would give us 1/8 e raised to the power of 2x plus c. So this would be your final answer. Okay. So usually if you are given with this type of example, kani siya ang dapat ang kani siya, if you're given this type of function x squared or x raised to any power, then multiplied with any other function, actually there's a shortcut for this one. So again, it's only applicable if muna siya ang case sa inyong given integral. So if you have here x raised to any power against any given function. Okay, so to do that, so let's try to use another color. So to do that is that you're just going to have here a table. So you write here the table. So this is the U parameter. These are the DV parameter. Okay. So first is you write the x variable. So you start off with x squared. Then the DV parameter that you want to be integrated would be e raised to the power of 2x. Okay. So let's start off with the left side. So again, since in the process of integration by parts, you're always trying to derive the u parameter. So derivative of x would give us 2x. Derivative of 2x would give us 2. Derivative of 2 would give us 0, di ba? So muna siya. So mustapa dire kay 0 naman siya. Okay. Wala po yung sense, di ba? Pag sige mo, derive sa 0. Okay, so next would be the integrals, which is on the second column. So e raised to 2x. So integrating, this will give you 1/2 e raised to the power of 2x. Then integrating the second line, so meaning included ang 1/2. So this would give you 1/4 e raised to the power of 2x. And then again, integrate the third line. So 1/4, then integral of e to the power of 2x would give you 1/8 e raised to the power of 2x. So mustapa diri kay 0 naman ang left side, di ba? So wala siya gamit if magsige mo padayon. So next is we're going to multiply diagonally downwards. So the first term is multiplied to this term. Next, this one is multiplied to the next term. Next is this one is multiplied on the next term na sada na. Okay? So the signages would be plus, and then this one is kanang minus, and this one is plus. So notice that upon multiplying the first term, it's equal to the first term here, di ba? So ang second term, so we don't know why it's not equal to the second term on our final answer. So let's try to check ano dili siya 1/2. So probably there's some mistake in my calculation kanina. So kuha na siya dai. Wala siya 1/2 dai kay dapat naman siya 2 dai dire kani siya. So I forgot to cancel out 2 dai. So the correct answer would be this one dai kani. So muna siya yung shortcut. So dapat kani siya should be 1/2 only. 1/2, and then the other one would be 1/4. Okay? So, muna siya ang shortcut version. So, you may do this shortcut version. So, again, as long as you are given with x to the power of n multiplied by any given function. So, any function dx. Okay? You may do this shortcut version. So, again, na-wrong ko sa akong final answer. Ako nasobra na siya 1/2 because I wrote 1/2 again and then I forgot to cancel this one out. So dapat ang ma-remain ani nga equation is kanira dapat wa siya 1/2. So that's why nasobraan siya og 1/2 sa akong two other terms kay kalimot ko cancel out. So muna usually ang mga so of course so even though I'm a teacher ta so marong yapon ta, di ba? So probably that's what you need to look out for in your exam. So try to be keen and observant on what terms should be simplified or should be canceled out ana siya para dili kay mo kuan sa inyong final answer. Okay? So so number 9 is e raised to the power of 2x sine 3x dx. So probably kani siya is magbalik-balik tag answer ani. So I'll just give you kanang the extra time for you to be able to solve this one, and then para sad na kuan sad. I think 8 examples are already enough for kaning kuan. So again, for para lang naatay tip kamay, so this one is my DV because again, it's more complicated in my terms. This one is my U. Okay? So any questions or clarifications with the topic? Okay, so if you don't have any further questions, so um, see you on um, Wednesday for our next topic. So for the deadlines for your assignment, I still have to change them. So wala po ako naka-change kay I was busy on the weekend kay I have to attend a wedding ba. Okay? So if you don't have any questions, so see you all on Wednesday.